The next question of Code Chef Starters 114 is Christmas candy. So basically, in this there are some places, let's say a Christmas party is going on, and there are some places, let's say they are zero based index for now, so until n minus 1, let's say. So basically at each position which person is sitting is given to us. So the person number is given. Basically there are n people in this Christmas party, 1 to n. So at each place which person is sitting, the number of him is given. So as number of people can't be same, two people can't be same, so for sure this array will be distinct, which is guaranteed in the constraint. So all elements in the array is distinct. Now a person can get a gift, can give a gift if the following conditions satisfy. So basically it's like ith person, it's with respect to ith person, whether ith person can give a gift to jth person or not. To know this, the following condition should satisfy. J should be greater than I, and a of j should be lesser than a of I. If this holds, then ith person can give a gift to jth person. So now this way we have the arrangement. We should say for this arrangement, how many people can receive at least one gift? People who can receive at least one gift. So if we look at the constraints, test cases are in the range 1 to 10% inclusive, and n is in the range 2 to 10%, and here it guarantees a of I is in the range 1 to n, and a of I is distinct. Every array value is distinct. So, and there is one more constraint given, that sum of n over all test cases will be less than or equal to 10%.
So yeah, let's see how we can solve this question with the help of a test case. So basically the two conditions that must satisfy are these: j should be more than I and a of j should be less than a of I. So let's just write them down here again. So j should be more than I and a of j should be less than a of I, right?
Yeah.
Which means now the jth person will receive a candy, right? So let's say the jth person is this, okay? Which means now I need an I value which is less than j. So any number from this, such that this a of j value is less than a of I. And if you observe in this part of the array, there is no value that is less than 6, and that is more than 6, right? Therefore, it's not possible for this person to ever receive a candy,
Yeah.
right? So from this, we can come with a basic idea that at every point, we need at least one person in the previous part of in the suffix part of the array, such that there's at least one person whose value is greater than this value, right? So can we solve this question by maintaining a max variable?
Yeah.
So yeah, let's see how we can do that. So what we do is we take a max variable. Let's say we initialize it with the first element of the array, because it's never possible for the first element to ever receive a candy, because there is no person before him for the value to be greater. So let's just initialize max with a of 0, and we start from the first element, and we go up all the way up till the nth person, right? Now at the second element, what we observe is the max value is already 5, which means there is one element before 2 which is greater than 2, right?
Yeah.
So we can say that we found one person. So let's just say that we found one person, okay? Now we come to 3. Also, at every point, we will update our max value if it can become greater. Like for instance, now max value is 5 here. When we come at this point, the 2 is not greater than 5, so we'll keep the max value as it is. We came at this point, we observe 3. Now 3 max value is greater than 3, so we found another person. We come here again, and again max value is greater than 1, so we got another person. Yeah. Basically, at this point also, our answer will be incremented with 1.
Yeah.
Now, we came at this point. Now at 6, we find that the max value is only 5, and that value is less than 6.
Yeah.
Which means before 6, there is no element which is greater. So our answer will not increase our answer in this case, but we'll update our max value.
Yeah.
Okay. So our max value becomes 6. So now we come at this point. Now the max value is 6, which is less than 7. So we'll still not increment our answer because 6 is less than 7.
Yep.
So basically, our final answer here in this test case will be 3. All right. So basically, this question can be solved in the time complexity of O of N.
Yeah.
Okay. So we just run a simple for loop, keep track of the max value, and check if the max value is either greater or less than the current element.
Yeah.
Okay. So yeah.